Today I'm going to do another one of these very good questions and interesting ones that you've sent me. I particularly decided to do this one because it's another review of the rules of logs, and also there are situations where two variables, two dependencies are not normal dependencies. They are more exponentially related to one another. So often you'll find that instead of plotting, say, y against t or y against x, they would be doing logs of one against the log of the other one. In this case, this is only this is logarithmic only in one axis, and the other axis is the normal t. So it's still a good question. If you find a question where both axes are logarithmic, then do send it to me, and I will try and do those questions for you as well. Here I've got the rules of log, so I'm gonna refer to them and use them. You have all access to this one. You've those who have called on my blog have direct access to these documents. So if you need them again, please come onto my blog and pick this and other resources, and of course the other videos as well. So let's keep this on the side of our work, and as we go down, we will use it. So here we see in a straight line, 2 points of these straight lines given. Sometimes in these graphs, for example, if we actually are studying the relationship between y and another variable, say t here, we may experimentally find some values, some plotting points, and then we may draw the line of best fit, and then using that line of best fit, try and find a relationship between the two variables. Here, of course, they've given us in a straight line. They have given us this point, which is the intercept point, and they've given us another point as well, which allows us to find the gradient of this line. So let's begin by finding the gradient of the line. So a gradient is normally shown by the letter m, and so the gradient would be the y2 minus y1. So the second y coordinate minus the first y coordinate, whichever one of these points you want to call the second one. So I'm calling this one the second point, and this one the first point. And then x2 minus x1. So in this case, the y of the second point is 4 log natural of 5, and the y of the first point is 2 log natural of 5, and then the x of the second point is 2 minus 0. So let's simplify this. So this would become so 4 minus 2 is 2 log natural of 5 over 2, and the 2's, these 2's can cancel, and that will leave you log natural of 5 as the gradient. So in a normal situation, you know that we show a line of a function of a line as y equals mx plus c. So m is the gradient, c is the intercept, and the axes in this case is y and x. But as you can see in our case, axes are a log natural of y, and the other one is t. So in our case, the function of the line would be log natural of y. So in our case, the y coordinate, y axis isn't actually y; it's a log natural of y, equals to m. So the gradient is log natural of 5, and times by t, not times by x, times by t, and then plus the intercept, which is this here. So it's 2 log natural of 5. Now to avoid putting this dot to show that we actually multiply these two together, I'm going to put t on this side, so that's more visible that it's multiplication, and I don't need to put that dot there anymore. And of course, this is also is 2 as a coefficient to log natural of 5. So I can take this in. I'm not sure how useful it would be, but just to practice the rules. So this rule here says that if you have a power, so if you have a power, then the power can be brought out and written as a coefficient. So here we have a coefficient, which is a 2, and is a log. I know we have a log natural, but it's still a log. And we can take this power in and make it, we can make this coefficient in and make it a power of the subject. So in our case, we can take these this 2 here and make it a power of the 5. So it becomes log natural of 25. I'll keep this on the side in case we need it again. So we have log natural of y is equal to t log natural of 5, and then plus log natural of 5 squared, so 5 to the power of 2, which makes it 25. Now I'm going to bring that log natural of 25, I'm going to bring that to the left hand side, so it becomes log natural of y minus log natural of 25 is equal to t log natural of 5. I could take this t in, so it becomes log natural of 5 to the power of t. But I can't really foresee the benefits of that. I probably can't even see the benefits of taking the 2 in making it more simpler. But I thought we'll just practice this rule. Now there's a second rule we can use here, and that is that the subtraction of 2 logs can turn into 2 subjects being divided, and that comes from here. So we have subtraction of 2 logs, log of a minus log of b. These are not log naturals, as I said, but log natural isn't anything other than log to the base e, which is a very specific number. And that turns into 2 subjects being divided. So the subject y and the subject 25 can be divided and made into 1 log. So this would become log natural of y divided by 25 is equal to t log natural of 5. So remember, this is the log natural is actually a log to the base e. So we can now use this rule, which is the very origin of log, and that is that if you have a log of a certain base and that's equal to n, then you can write it as an exponential by saying that base to that power is equal to a. Base to that power is equal to a. So the base here is e. So base to that power, base to that power is equal to this. Yeah. So if I can maybe write the e here, so you can see that there is a base there. And let's reduce the size of this. So we say base to that power is equal to the subject. So therefore, the subject, which is y over 25, is equal to e to this power. So we're very close to find y in terms of t, and all I have to do really is to move this 25 to the other side, so it will be multiplied by the other side. So y would be equal to 25 times e to the power of t log natural of 5. Okay, so that was another good review of these rules. If I can do so many other questions to help you use these rules so it does settle with you, then I will do it. If you find some good ones, send it to me and I will do it for you. This communication that's going is pretty good, because what we end up doing very critical questions which everyone would benefit. And do please leave your comments on my YouTube page, on my own blog, and also wherever you see these videos, and I will respond to them, and I will definitely respond to any challenging questions that you will find. And if you post it to me, I shall make another video, make videos on them, and post them on my channels, and I will also inform you that I have posted them. So look forward to seeing your other questions. See you later.